Good morning, ladies and gentlemen. I'm very honored to be here speaking today at GPD. When asked to speak at this event, you always struggle with what can you say in 20 to 30 minutes that people can leave the auditorium with, go back and actually make a change in something that's happening in the glass business. So what I want to talk a little bit about today is step change innovation and the clock speed of the glass industry. And some people maybe have heard me speak before. I always confront the brutal facts. I try not to mince words or hide the facts. And I think it's very important that as a glass industry, we realize today that we are not in a state of temporary turbulence. We are in a very different place today than we were 10, 15, 20 years ago when glass consumption in kilograms per person was growing at a rapid rate. Many of the world markets today, such as North America and the European Union, are in a steady state or a decline. So as fabricators and glazers and architects and glass companies, how do we make money and how do we fulfill what the industry has as untapped potential is critical. And in my mind, it all starts with innovation. To me, glass is a fabulous building material. People love glass, architects love to design with glass. Glass is used everywhere. But there are many challenges today that are coming and facing and putting pressure on the use of glass. One of the things that's hurting the glass industry today is we've adopted what I call an incrementalism view on innovation. And in a little bit, I will give you some timelines that show the history and the evolution of what we've actually done to a facade opening since 400 AD, and in retrospect, it's a little depressing. Okay, when you compare the glass industry to other industries, they've made rapid transformations where the glass industry is very incremental in nature. And this is something that needs to change or there will be less glass used in facades. And one of the things that we need to maintain our space in the wall is that we have to create greater value through the entire chain, and I will touch on this topic. We also need a faster industry clock speed. I read a book that was written by an individual at MIT Sloan Business School, and he basically labeled the glass industry as dinosaur, with a clock speed of 15 to 20 years. That means we only implement major innovation every 2 decades. Businesses, industries that do that do not survive profitably long term. This is something as an industry we need to address, how we accelerate the clock speed of innovation. And this in the end has to be driven by the user demands and the unmet needs, and they have to be sustainable. So I'd like to briefly just, what is driving, and any time in an industry you have a few metrics or key indicators that drive what is happening in the business. We all know about global recessionary conditions. We all know that energy costs in many countries other than the US and Russia continue to go higher, which is going to put more pressure on the performance of glass and facades. The energy codes are tightening, and I'll explain a little bit how they're tightening faster than the rate that we are innovating. And we need to realize that the true competitors are not the fellow fabricators in the room, they're not the fellow architects, they're not the fellow glass companies. The true competitors are brick, stone, solid surface building materials that basically reduce the overall window-to-wall ratio. And there's an ever-pressing need to demonstrate payback on innovation. A lot of buildings start out with great innovation, but then they're costed out because the return on investment is insufficient. And obviously, we have to focus on sustainability and the carbon footprint. Now, as an industry, how dependent are we on facades? This pie chart just briefly illustrates by metric tons where is glass consumed. And as you can see, between residential facades and commercial facades, you have roughly 70 to 75% of the glass consumed. This is an industry that is very, very dependent on the window-to-wall ratio. If the window-to-wall ratio reduces, so does that size of the pie. And no one in this room benefits from a reduction in the window-to-wall ratio. Now, one thing I'd like to do is talk a little bit now about what is the impact of the window-to-wall ratio on the business. When you look at a facade today, a typical building has about 40% window-to-wall ratio. So that means 40% of the building is window, 60% is wall. Okay? One thing we need to do as an industry is we need to migrate from thinking in terms of metric tons to surface area. A lot of times when you look at a building like this and you see a 1 meter squared opening, you say, okay, that's 1 meter squared. No. There's 2 pieces of glass, 4 surfaces, there's 4 square meters to add value. As the market goes to triple glaze, now you got 3 pieces of glass and 6 square meters to add value. So it's very important that not only we look at what is the window to wall ratio, but what is the available surface area that we have to add value to the glass. But what's happening is rather disturbing. And what you'll see in the graph on the left is in the US, there's ASHRAE, there's IECC, there's NFRC. What you can see since 1998 in U-factor, how the codes are tightening. Every 4 to 5 years, the codes are going tighter and tighter. That's driving requirements for new coatings, new insulated glass technology, and changes in sash, frame, and curtain wall design. But there's a problem. When you look at the yellow line along the bottom, that's what we're now being compared to. Steel and wood solid surface walls. There's still a large gap. So what's happening in the US right now, the government wants to change the window to wall ratio on the prescriptive path from 40 to 30%. If that were to happen, we would lose 25% of that pie chart in facade glass. And part of the reason why I think this is occurring is how we've achieved that improvement has been through magnetron sputtered coatings, single silver, double silver, triple silver. The problem is it's all incremental, and the gap that we have with the other building materials is still too great. Therefore, there's the need for step change innovation. And right now, I've seen articles in India, I've seen them in Brazil, I've seen them in Malaysia, the US, and parts of Europe. This is becoming a growing problem. So what does a building look like if you go to 10 to 20%? It's very obvious. The windows become smaller. You tend to go to more strip windows. You're going to have less curtain wall, and you're overall going to have a building that is more dominated by concrete, stone, and building. And we actually have architects around the world right now that are migrating to this path because if they want a true green building, in many climates, they're using less glass. Now, with many of the innovations we have been around. They've been existent, they've lived in the labs. The problem is, we have a problem in the supply chain. How do we get these technologies and products commercialized? I'm just going to put up a few examples. I'm not going to go through them due to time. But many of these technologies have existed or are very near commercialization. The problem with all these, there's a step change in the price point. So right now, we really focus on cost and then the ultimate price through the channel. And what's happening right now is a glass company will go push electrochromic, but it may not be supported by the fabricators, it may not be supported by the glazers or the installers. Part of the challenge we have as an industry is if you take electrochromic, what does each level of the channel have to do to extract value for that technology? Now, it can't cost $100 a square foot. It has to be reasonable. But as manufacturing costs come down, we have to, as an industry, figure out how do we do a new fit, form, function into the facade opening. When you look at our historical chronology, right now, we don't have to change anything. It's a double glaze. First, it was 2 pieces of clear, then we added coatings, then we went to warm edge spacers, then we added argon. That's incrementalism. The industry is very good at just piecemealing a little bit of added value, but it becomes a cost plus structure. We're not extracting the value, therefore we're leaving massive, untapped profit potential. So when you look at a building that could be 60%, there are technologies that exist today between electrochromics, vacuum insulated glass, vacuum insulated panels, building integrated photovoltaics, that this should be what the innovators attending this conference should strive for. This is what we want the building to look like. And it is within reason, but it requires full participation through the channel. Now, another thing that's coming a problem, okay, in my view, is that the glass industry has a clock speed of 15 to 20 years. What this means between major changes in innovation, that is the time period. When you look at semiconductors, they have 1 year. Look at the iPhone. The iPhone, major changes year to year. Okay? You look at the automotive industry, it's 5 to 7. Pharmaceuticals is in 10 to 12. Glass, we are lumped with timber, steel, aluminum, and glass. Glass is too sexy to be lumped with timber. The other problem, though, that's converging when you look at that previous chart on codes, if we're evolving at 15 to 20 years and the codes are changing at 4 to 5, at some point we're not going to be able to incrementally innovate enough to keep up with the code changes. So to me, that is one of the big issues I see in the industry right now, is we are not innovating at a fast enough rate. But you can't do step change innovation without a new clock speed. And one of the things that I'll touch on in a few minutes is what I call the full value chain. When we're working at Guardian on the vacuum insulated glass, we can't do vacuum insulated glass by ourselves. We need equipment partners, we need material partners, we need supply chain partners, we need from raw materials all the way to the end user a continuum of support and people that are invested both financially and administratively in the process. The other thing is we have to have simultaneous product design. One of the reasons is I kind of take a 50,000 foot view of the glass industry. Everybody works in their own silo. The glass companies go off in their R&D centers and innovate. The sealant companies are off innovating in their own corner. And everybody wants to hold exclusive value to themselves. But in the end, no one wins. So it's very important going forward that the product, the equipment, the process, and the supply chain all need to innovate together. And obviously value creation at each level in the chain. Another thing is we have to become more of a pull as opposed to a push. Now this chart for me was a little disturbing because I said, okay, let's go back. Let's go back and look at what has happened in the actual glass industry in terms of major innovation. Thank you. And this chart to me is depressing. When you look at this, flat cast glass first came around in 400 AD. We went to rolled plate glass in the 1840s. We went to machine-drawn glass in the early 1900s. And then Pilkington with the float process in the 1950s. And then pyrolytic became some mainstream in the 70s, sputtered coating in the 80s. So when you really take a step back, for 2,000 years, this is what we've done. Not too impressive in my mind, okay? So one of the challenges we have is how do we change this? And one thing we all need to be very aware of is if it wasn't for sputtered glass, low E solar control coatings, there would be a lot less glass today. But how long can this industry ride sputter coatings? Because this is where I see the biggest challenge for this group. When you went with pyrolytic coatings, then the sputtered answer was no silver. So if you look at the lower graph, this is the light to solar gain, so it's solar heat gain versus visible light transmission. You'll see that we first went to no silver, then to single silver, then to double silver, and now triple silver. The problem is when you go to 4 silvers, you now reach the point of diminishing returns. So what is the industry's answer to sputter coating basically becoming less of an incremental gain. We have to figure out what is going to happen after sputter coatings. Now, when you look at the actual fenestration opening, you see a similar story. So not only has the glass fabrication, glass producers not innovated, what's happened is when you look at fenestration, monolithic glass in that 400 to 700 AD, the first double glaze roughly in the 1930s. In the 60s, we added the box spacer. In the 70s, added argon gas, and then in the 80s and 90s went to triple glaze. See, to me, this is what I call brute force innovation. Okay, we have a piece of glass, let's add a second one. Now let's change the spacer, let's change the coatings, then let's go to triple glaze. But now the units are becoming heavier, the costs are growing up. So really, what can we do as an industry to change, and what is that next step? And because we were in Finland and everybody here knows Nokia, you know, I wanted to use an example. I'm not going to go through this whole chronology here of the phone, but you can see it. But here's an industry that basically had a very similar clock speed to the glass industry. Sometimes 40, 50 years. But in the 80s, they realized that there's more potential to a phone than just making a point-to-point call. And so when you look at what's happened to the phone from 1980 till now, the clock speed continues to accelerate. Okay? 30 years ago, people didn't envision that they would be taking pictures with their phone, that they would be sending email, and that they would be doing a whole host of activities, making dinner reservations and, you know, organizing meetings. So here's an industry that has increased 20x its value because of what it perceived its industry could be. So when you look at glass, very slow clock speed. When you look at the opening and the fenestration, a very slow clock speed. This is where an industry like the phone business, it wasn't just a Nokia or a Motorola or an Apple. You needed semiconductor devices, you needed new software, you needed cell phone towers. Here's a prime example of where the whole supply chain worked together and everybody won in this process. So the question for this group is, how, as an industry, do we start to work more together in collaboration, in concert, to increase the value per opening and the value of the glass in the building? To me, it's doable. I had a hard time deciding, do I take the phone or do I take 15 other industries that in the last 50 years have transformed? But I think right now, with the energy code pressures, with the changes coming, this is the time we need step change innovation in this business. And I just want to talk briefly about a concept. There's a good book. I should get a kickback from this guy for helping him. But there's a book called The Wide Lens by a guy named Ron Adner at Dartmouth Business School in the US. And this picture here says a lot, I think, about the glass business. Every company is very strong and very good at executing. We have a very strong execution focus in this industry. The problem is our peripheral vision is pretty bad. Okay? And part of that is because we don't think about what co-innovation or co-invention is required. When you look at the adoption chain, what does each level of the chain have to do to be able to accept that technology? When you go back to the phone analogy, if you would have just developed the best digital phone but didn't go out and install cell phone towers, you wouldn't sell any product. If you went off and developed the Android operating system, but you didn't have the functionality in the phone, then you wouldn't be able to sell the software. So the amount of industry collaboration required for the phone is mind-boggling. Our channel is not that complicated. A glass company sells to a fabricator, who sells to a glazer, who sells to the general contractor, and it's installed, in a design from the architect. We have to be able to figure this out. And just to elaborate on the chain, the cell phone industry has almost 25 steps in its value chain. When you really take a step back here, and if you incorporate in suppliers, we have 5 to 6 levels in the value chain. When you look at other industries, we should be able to innovate at a much faster pace than many industries. But what it does, it requires each level in the channel. Now, when you look at the adoption chain risk, this goes back to the execution focus. And what I'm just trying to portray here is that when you look at the top, there can be things that are great for the glass company that generate record profits, and there can be huge value for the owner and the developer. But what happens if the glazer, it's a negative? The glazer's costs go up and their margins decrease. Is the glazer going to be interested in migrating to electrochromic if he makes less money? No. So this is where, and you look at the bottom, the glass companies, us included, are going to have to sometimes say, okay, maybe we can't eat all the margin because we need to make sure that there's enough value through the chain to enable the launch. Because all it takes is one person in the chain to not adopt, and the technology is of no value to the end user or the consumer. So it's very important that we go through these steps, we build the industry partners, and get the people on board that we need to commercialize the technology. And I'm not going to go through these for time, but I just wanted to use electrochromic as an example. These are all the things, and this is probably missing some, but you go back to every step in the channel, these are activities that every step needs to do. So, you know, the glass producer can go off and make the best electrochromic glass, but if we don't have the right sealant properties, can't sell it. If we don't have good solutions at the fabricators for the wiring, the electrical harness and the connection, not going to sell. So electrochromic will never become a viable technology unless everybody in the chain is willing to invest to extract that value. And this is just from the adoption chain. Now when you look at innovation, which applies to most of the participants at GPD, there's many levels of the channel that have to really push the envelope in technology. So just in closing, I think it's important that we understand who the true competition is. Sometimes I think there's too much infighting in the glass business. The focus has to be on more glass and less alternative building materials. And we have to understand that right now with an incrementalism approach, it's a very temporary advantage. Okay, we come out with a new coating, a competitor comes out with a new coating. We go to a triple glaze, somebody else goes to a triple glaze. So part of the reason there's been a stagnation in returns in this industry is it's too much of an incrementalist approach. We need to create value at each step of the adoption chain. This is very difficult though when you get into new technologies because it requires investment at each level. And I know times are tough. Many industries in many parts of the world right now are in severe depression when it comes to the glass industry. When you look at Europe right now, 15 float lines are out of commission. In the US, 12 have gone out of commission over the last 5 years. So it's obvious there's less demand for glass in the US and in Europe right now. So everybody's shrinking their businesses, they're watching their cash flow. But this is the time where if we don't innovate and we don't allocate some money to additional R&D, how do you ever get out of this hole? And I think one thing is we really need to eliminate the co-adoption and co-invention risk in this industry via partners. At Guardian, we're really looking hard to find the right equipment people, the right raw material suppliers, the right entities in the business that can help us get to market faster. So we've really started focusing on what I call TTM, or time to market. Okay? We don't want to be launching new products every 15 to 20 years. We want to be coming out with innovation, meaningful innovation every 5 to 7 years. The other thing is we need to increase the industry clock speed through R&D spending and alignment on critical drivers. And I just want to make an analogy here. In the semiconductor industry, there's basically a function called Semitech. Okay? Semitech was formed many years ago in the semiconductor industry, and it was the equipment suppliers, the raw material suppliers, the chip makers, it was the computer companies, and they actually worked towards an industry roadmap. Now, I know Intel and Texas Instruments and Siemens and all the other players all had their own product roadmaps, their own vision, what space they wanted to play in. But as a macro industry, they had certain targets and sight set. And I think this is one of our challenge today. There's not many things left to do to glass in a facade. You can control the transmission, you can generate electricity, you can improve the insulation value, you can improve safety, sound, and security. So we do have a finite number of options. So I think this is where, at least from my point of view, we will be pushing more to create more collaboration with different levels of the value chain so that we can implement the step change in innovation. And I think one thing is you always still need incremental because you got to keep the lights on and you have to pay the bills. Incremental evolution will never go away. But the problem is if we only depend on incrementalism and do not implement step change innovation, we will see a reduction in the window to wall ratio and we will see less glass. So to me, I looked at a lot of the topics and I looked over what some of the papers were discussing, and there's a lot of interesting things this week. But one of the key things is you can have a great idea, but how do you get that product in the building? So that would be the other challenge for the people here this week is how do we do a better job of taking those ideas, those kernels of innovation, and how do we get that to where we actually can walk down the street, look across, and see that innovation in the building. Okay? So thank you. And that's what we hope one day is that we have a complete world with glass. Thank you.